So this is the ds-incubator, and again we are in the series about exploring data with the tidyverse. And today we're going to be talking about variation and how we can explore the variation contained in two kinds of variables, categorical and continuous. How can we do that with two tools, the Gplot 2 package and the Deepplier package, both part of the tidyverse. So what you're seeing here is the typical syllabus. We are trying to first understand the role of questions in an exploratory data analysis. We're going to be also reviewing very quickly definitions that we're going to be carrying throughout the rest of the series in terms of definitions of the main components of your data. And then we're going to be exploring categorical variables, continuous variables, both with visual tools and with analytical tools. And we're going to be also exploring the distribution of multiple groups of a variable containing the data set, all in a single plot. So what you are going to be seeing today is here in this RMD document, in this R Markdown file that we talked last time. An R Markdown file is one tool to communicate with yourself first and this with the world. What are your findings about your data? So the first thing I like to do in my scripts or in my R Markdown documents is to start with the packages that I will need for that particular analysis, and that is a way to very quickly advertise what things this analysis depends on. So one really cool trick that or feature that the tidyverse that RStudio has is that if you mention a package that you don't have installed, then RStudio will let you know. So for example, I don't have the package vegan. Vegan is the name of a package, and it's a real package, but I don't have it installed in my system. So as soon as I save the file, notice how here on top I get the sign package vegan require, but it's not installed. And I can click here in install, and it will automatically be installed. So it's really cool to do that. So that's one reason to advertise very quickly the packages that you need. So anyone running that analysis, trying to reproduce it, even if it's yourself in the future, very quickly know what they need to install. So the first component here of this meetup is to try and understand the role of questions in an exploratory data analysis. So the questions are basically the tools that you have at your disposal to focus your attention in a specific part of your data. And the idea of actually doing an exploratory data analysis is all about trying to understand your data. So those questions then are the tools that will best help you get that understanding that you want to gather from your data. And although for each data set there are specific questions that you may need to ask, just about any data set is, will benefit from asking two types of questions. So one is the question of what is the variation contained within a particular variable, and you can ask that question for each of the variables in your data set. And the second kind of question is what kind of covariation occurs between two variables. So I have variable X, variable Y. Is there a pattern is there a pattern that is contained? Every time something happens with variable X, is there anything that happens consistently or systematically with variable Y, or are the two variables completely independent? So that kind of question. So that is just about everything that is covered in the chapter that we're covering in this series. But today we're going to be focusing on point one, on variation. So basically focusing on one variable at the time and trying to understand how that variable changes with different values. So let me jump to very quick definitions. The very quick definition of the main components. Sorry for the background noise. There we go. So the very simple definition of the main components of the data set are these. So basically, because I assume that most of us here have experience with spreadsheet-like data sets, then we can think of a variable as a column, a value as a cell, and an observation as a row. Then how you actually define the column, the row, and the cell has to do a lot with your particular problem. So what is a variable for you is something quite specific, but there is something interesting that someone wrote a paper about what it is, what they call tidy data. And it's a very simple way of thinking about data, and a very useful one, as one that is used in the tidyverse. The idea that a data set is tidy when each variable, so each thing that varies, whatever you define it is saved in just its own column, as you see here. So each column is one variable. Also, when each observation, and an observation is basically a set of measurements under the same condition. So if each observation is in one row, right, and each variable is in one column, then your data set is what they call tidy. And the tidyverse, which is this set of tools, use that idea to develop tools that expect that type of data. So if your data does not meet that simple requirement, then it's going to be very hard to use the tidyverse to, for example, visualize data or analyze data. And then the tidyverse does have other tools to actually reshape the format of your data to comply with those conditions. For a more formal definition than the one that I have given about, let me see here, about the definitions question here, about variables, observations and values, I recommend you go to the book that we are using, chapter 7, Exploratory Data Analysis. In the subsection questions, you will find a more complete definition of what I have just said. I just summarized that as, a variable is a column, an observation is a row, and a value is a cell. But for more formal definition, go to the book. Okay, so let's, unintentionally I'm installing the vegan package, which wasn't my intention. I just wanted to demonstrate that. Okay, next expand this a little bit more. So one example of a dataset and how it looks in R is, for example, the dataset diamonds that comes with the tidyverse. More specifically, it comes with the package Gplot 2. And here you can see already that there is a bunch of columns, or we can talk about them as variables, which we just learned we are defining as the same thing. And in particular, notice that there is a column, for example, called cut, and it has the values, a small set of values like ideal, premium, good, very good, fair, very good. It's not a continuous variable, it's a categorical variable because it can only take a very limited set of values. Then notice that there is another column here, for example, carat, which takes values that like 0.23, 0.21. So that is a continuous variable. So one that takes an infinite number of values along an order kind of sequence. So those two types of variables are going to be the star of the show today. And we're going to be using Gplot 2 to try and understand how the variation is, what is the variation contained in each of those types of variables. So to start, we're going to be starting with the column cut, which is a categorical variable, and we are going to be exploring the distribution of that variable. Why is that important? Well, because every variable has its own pattern of variation. So the idea of, okay, I take one particular variable, in this case, cut, the cut of the diamond, and I measure it twice. Do this, how, from one measurement to the other, what is the change in the value that I get of that variable? So that is the idea of variation within a variable, and there may or may not be some specific pattern. So maybe the distribution of the values in that variable are at random, and maybe not. Maybe there is some pattern that we can extract and think about, and that is the insight that we are actually after when we do exploratory data analysis. So the best tool actually to understand that pattern, and thus to understand your data, is the simple plot, the visualization, right? And that's why we use the tidyverse. So before we do the first plot, let's first think a little bit about the column that we're going to be looking at. So I'm using here the function relocate, which basically takes the name of a column and puts it in the first position so that it's very easy to see it relative to the rest of the data set in that data set. So here what I'm showing is that it is, just to remind you, that this is a categorical variable that takes just a very limited number of values. It's not a continuous variable, it's a categorical one. So, and we're going to be using now ggplot 2. Remember, using the template that we used before in the last meetup. Basically, it's always called the function ggplot 2. In the data argument, we are going to say this time we want to plot the diamond data set. And then there is some kind of geom that gives you the geometric representation of the data on a coordinate system. So in particular, we're going to be choosing the geom bar because we want to represent the instances, so the count of the different values like ideal, premium good. So how many premiums do we get? How many goods do we get in this data set? So this is then how you do it. So again, the template always takes, these ggplot2 functions that takes the data set, and then we give some kind of geometric representation, in this case a bar, and then the mappings is this idea of mapping a particular column to the x-axis or the y-axis. In this particular plot, we need only one variable, only x. So let's run that. So here I get an error because I forgot to run all the chunks above the chunk that I'm standing right now. So I've done that before, and now if I click here on the little arrow, I do get the plot. So the plot is just the one that you will see also here on the document that I'm sharing with you. So here you can see that the plot automatically counts the number of fares that it sees in the data set. It counts the number of goods that it sees in the data set, very goods, premiums, and ideals. So this is a bar plot, and this is how you actually do it with the Gplot 2. So if you wanted to do this by hand, you can. Basically, you can use Deepplier, which is another tool in the tidyverse, to do just about the same thing. So what you do here is you remember how we read this pipeline before, take the dataset diamond and then count the number of instances of the variable cut. So what you get here is a new column named n that gives the number of instances of each of those values of the variable cut. So this n column is the one that is plotted here. So internally, the tool ggplot2 does the same thing that you could do here by hand. Right, so if you wonder how you can reproduce that plot, analytically, this is what you would do. So these two things are showing the same thing, one in the form of a graph and the other one in the form of a table. So depending on what is the use of, depending on what you want to communicate, maybe a table or maybe a plot might be more useful for you to use. So now let's move on to talking about the other kind of variables that we're going to be covering today, which is a continuous variable, which, as we said before, a variable is continuous if it can take any infinite set of ordered values, right? So let's do the same that we did before. Let's use the function locate. So let's take the diamonds data set and then let's relocate the column carat to the first position. So carat is, just to remember, is a continuous variable that takes values such as 0.23, 0.21, and so on. So now we can also use visualization tools to explore the distribution of the values of that variable. So how we're going to do that? Okay, again, remember we use the template. We take the function ggplot2. We give it the name of the data that we want to use. In this case, take the dataset diamonds. And then the next thing we do is we use some kind of geometric representation of the data for continuous variables. Before we used geom bar because that is the tool for categorical variables, but here we are using histogram. Histogram will first create a categorical version of the continuous variable so that it can create columns that then can show you on a plot. So the mappings, again, we map the variable carats to the x-axis, right? Here is the mapping. And then we're going to choose how wide we want those columns to be. So we could omit that argument there and run that code as it is. And ggplot2 will just guess some kind of width for the columns. But it is a very important argument, and in histograms you will almost always see it used because it is very insightful to try different bandwidths to see if you may be missing some fine-grained detail that might be contained in a column that is too wide, or maybe quite the opposite. Maybe if you get a lot of columns that are too thin and they all represent the same thing, you may summarize them better in a wider beam width. Sorry. So if I run the same plot now with beam width 0.5, you can see how the plot changed a little bit, and now it's equal to the one that I have here on my right. Let me scroll down. Yep. And it may or may not be the most informative one. So the best thing you can do is when you do a histogram, always try different bandwidths here. You can try 75 or whatever you find it might be useful for your use case. Good. And the same thing you can do by hand. So remember that carat is a continuous variable. So the trick here, as Gplot2 does internally, the trick here is to use a function that creates a categorical variable from a continuous variable. And that function is cut with Unfriend. So if I ask for the health file of that file, I'm going to press F1 on my keyboard. You can. Thank you very much. Thanks very much. I can see the health file of the function cut with Unfriends. I can see that it has the gang here are three functions: cut interval, cut number, and cut width. The three of them help us do similar things. Here we're using cut width in particular, so we want to cut a continuous variable in chunks of, or in bars that we're going to represent in bars, but in little chunks of 0.5 width. So if we do that first, so that's how we first cut the value, the column carat in that width, and then we count the instances that we have for each of the different bars, right? So this would be the analytical version of the histogram that we have here on our viewer. What would be down here? There we go. So this is to the right, the histogram version of this analytical table type version. Okay, so we are getting close to the end. There's only this one other thing that I wanted to mention, that is this idea of, okay, what if you have multiple groups of data within your data set, all corresponding to, in this case, for example, carat, and you want to overlay them. Well, actually, the point here, the very first point was here, is to demonstrate the value, of trying different bandwidths, just to see if there's any pattern hidden in the bandwidth that you chose. But the overlay thing is this one here. So the idea is the following. Sometimes your data set has different groups in a variable. For example, you can explore the value carat by different colors. So by different cuts. So what is the carat for diamonds of ideal cut, or what is the carat for diamonds of premium cut? Okay, so the way you plot that idea is this way. Remember, you take the function Gplot, you give it the data set. In this case, the data set is the one that we created in the chunk above here. It's simply taking the diamonds data set and then filtering for carats that are smaller than 3. So that's how we created that data set smaller. So let's make sure that we have all that information here by clicking the down arrow. And then in the mappings, what we do is we map the column carat to the x-axis, right? And then the cut, we tell Gplot to map the different cuts to different colors in the line. So before, everything you've seen so far has been black and white. All your bars of everything has been black, and now you will see different colors. So now the tool that we want is not geom histogram, but instead geom freq poly, so a polygon of frequencies. So this is another type of function in Gplot2 that allows you another geometric representation of your data, another geom, that allows you to plot very clearly different groups of data in the same data set in a way that you can see what's underneath. So if we were using a histogram instead, let's try that. I'm not sure if it's going to work. I think it will. Histogram. What you would get is like this overlap that makes it really hard to understand the data. So that's why when you have overlying data sets or overlying groups of data within your data set, a much useful tool is frequent freq poly. All right, so you might be wondering by now, like what, how to even know what are the different geoms, for example, that you can use for the different, visualization problems that you may have. So here I collected a bunch of resources that I find really useful. First of all, the first link will take you to the Gplot2 package website. Here you have a link to the template that we were talking about the last time. The very first one I'm going to be clicking on is the reference. I find the reference of this package, basically a reference is a list of all the functions that it contains. I find the reference in this particular package extremely good, extremely useful. And why? Because here to the left you have a little icon of the different kinds of plots that you might want to do. So you don't need to know too much about Gplot2 to kind of get your way around. You just come here to the reference, kind of scroll down, see what type of geometric representation of your data you are looking for, and then see which is the function that does that. That's the trick. Finally, before ending, there's a cheat sheet as well that is extremely good. It takes you to the website again. You can click here and download that cheat sheet, and it contains a lot of information packed in a very compact way. And finally, the reference for Deepplier, because we have been doing not only plots, but also some analytical things. And although Deepplier is a huge package and has a ton of tools, the reference is also very good. It's very well organized, and you can see just, for example, in this first heading, one table verbs, you can see a few functions that they are all very useful. And I recommend, clicking in each of those URLs, in each of those hyperlinks, and reading the help file, at least of these very few set of functions. Just with these few tools, you can get a lot done in Deepplier. Okay, and that brings us to the end of what I wanted to show. So I'm going to bring your pretty faces again and ask you to bring your questions or comments to the room. Jakub, go ahead. Yes, Jakub, go ahead.
So there's this idea of tidyverse. Is it the same thing as one data set, or can I have like a longer data set where one column is the names of variables and use the same tools?
Can you repeat? Your voice came out a little low here on my computer.
So I want to know, like, how does this idea of tidy data relate to like wide versus long data set? Can I use this on a longer data set?
Yeah. Okay. Excellent. You can have tidy data in both in wide and long format, but it's true that sometimes, depending on how you have defined the variables in your data set, that might be a sign that it needs tidying. Like, for example, a column may contain something like year underscore. What else? That could be year underscore and some kind of number. I know, because there is a value for a variable that happened in a particular year. So that column is untidy in the sense that one single column encodes for two types of information. One information belongs to the variable year, and the other information belongs to the variable value. So in that case, you need to first separate those two variables from the column that is an artificial variable, and then you will be able to do your analysis more comfortably. Then what you say, which is not exactly what I responded to, is this idea that once you have those years in like one in a row, depending on the use of the data, sometimes you want those years to be each one a column. More usual than not is the opposite, where you start with a spreadsheet that, for example, if you collect data in different years, it is very common to have one column that says year 2020, and then you do everything that you want in that data set. Then next year you come and do another measurement, and then you don't add rows, you add another column that says year 2021, and then year 2022, and then year 2023. So throughout the time, your data set accumulates observations as rows. But then that is a wide data set that is very good for looking at it in the form of a table, for example, for publishing in a paper, but it's very uncomfortable to work with in Gplot 2, for example, because Gplot 2, wants to know, okay, what is the variable, the single column that contains all years, and then in that case, that is a wide type of data set that has the variable year spread across multiple columns. So what you want to do is to pivot all those year columns into a single one, so that the columns become rows, and now you have a single column called year, where the different rows belong to different observations for year. So that's how the idea of tidy data relates to long and wide. It's not, once you have it in a long format, moving it to wide won't make it untidy. It's just a different form, and depending on the tool that you want to use, it might be better or worse.
Yeah, thanks.
No more questions or comments? All right, thanks a lot then. For once, we end sharp at 9:30 on my time. Whatever time in the world you are, we are ending sharp. Thanks a lot. See you next time.
Bye.
Ciao.
Thank you a lot.
Thanks.